On the bench here today we have a FT857 from Yaesu, and the radio came in with no TX audio. So that is what we want to test first, and then we want to see what the problem is. Okay, I've set the radio onto the 20-meter band, and well, it is set to FM, so let's first check if we have any audio, so that means deviation on the deviation meter, to see if there is audio or not. So therefore I gonna key the PTT, and yeah, it is switching into TX, and what we can see is that the radio is producing RF, so that is approximately 90 watt RF, so that is good up to here. And I have as well hooked on the deviation meter, and now audio 1 2 3. So in FM we can clearly say that there is no audio, so I'm permanently talking into the microphone, and yeah, so there is no audio on FM. So let's switch to let's switch to AM. So what happens on AM? Keying the PTT, and yeah, we will have 25 watt carrier, and again there is nothing. So let's change my meter to AM and see if we have any audio. So keying is okay, but that's right, there is no audio at all on AM. So therefore let's go to, let's set it to upper sideband, SSB, and yeah, let's see what happens when I key it without audio, no carrier, so that is okay. But now 1 2 3 4 audio, 1 2 3, yeah, nothing at all. So that is true that we do not have any audio, so that is exactly what the OM has told me, so no TX audio. Well, what we know is already a lot. So we do not have audio on SSB and AM, and not on FM. And as you might know, FM and SSB are completely different signal passes inside the radio, and well, therefore we have already narrowed down the problem, and well, it is from my point of view, the problem must be somewhere in the TX audio signal path. So that means really right from the microphone where we talk in to up to the point where we have, you know, that is exactly what you may have seen in my last tutorial concerning the TX audio signal path. So we have a microphone amplifier inside the radio. We have, of course, a limiter. We have, of course, a low pass filter, and then after that point the signals get distributed in a different way. But due to the fact that we do not have TX audio either way, so on SSB and on FM, so I guess the problem is somewhere, yeah, let me call it front end, in the front end TX audio processing, however you want to call it. So yeah, so let's start with our first test. Well, and where can we start when we have TX audio problems? Well, very simple. Start point should always be the microphone, and well, microphones are known for producing trouble, so that is the reason why we really need to start here. Unfortunately, I do not have exactly the same microphone for testing, but I have another MH31, but with a different cable and with a different plug at the 857. On both sides we have this yeah, let me call it Western connectors, and that is a good thing. So we can simply disconnect this wire, and we have my spare microphone for itself, and the same we can do here at the radio. So we put this one away and take the spare one, and we connect it to the microphone, and well, let's see what happens with the new microphone. And well, yeah, just to repeat it, the microphone should always be the first test. And I mean, there are different ways of testing it. Well, the easiest way is if you have a spare microphone, as I'm doing it right now. Yeah, radio is still on the 20 meter band. It is still on upper sideband, and well, let's see what happens with the new microphone. Okay, I'm keying it, so we see transmit light is coming up. Now we do not see anything, so that is right. And now, oh, have a look. Audio, 1, 2, 3, 4, audio. Yeah, and yeah, here we have already the fault. So that is that seems to be an easy repair, but anyway, let's switch to AM as well, and let me connect again my modulation meter. Yeah, it is still switched to AM, and on AM the carrier is 25 watt, and now audio 1 2 3, audio 1 2 3. So you can see audio is there, modulation is available. So let's do the same again for FM. So we switched to FM. Let it switch here to FM as well, and let's see what happens. So carrier is available, and what you can see here, so audio, 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 so that is very close to 5 kilohertz deviation. So audio is also available. So that will become an easy repair. So we know the radio itself is working, so we do not have a problem with the radio. So there is a problem with the microphone. In this case, that means that the cable is okay, because I was not able to change the radio, because I only have a different one with a different plug, so I can't use it here at the 857. But anyway, it is already working, so we do not need to take care on the cable. So next will be to open up this microphone and see what the problem is. I mean, we know that the PTT switch is working, but it does not produce any audio. So yeah, let us check why we do not see any audio on our meter. Yeah, I've opened the housing of the microphone, and there is nothing obvious right now. It looks a little bit as somebody was already in, so there are some marks here on the PCB that somebody may have soldered a little bit here on the PCB, but anyway, so it can also has happened in the factory, maybe during final test, I don't know. So that is not a clear sign, but something was going on. So yeah, there is really something on the board, and well, but nothing really additional. Yeah, so we need to open it completely. So I have to take off these screws, and then maybe we can see on the other side why we have here flux on the board. Yeah, let us open it completely. Oh, this is the whole board with a dynamic capsule, and well, On this side it is all in good order, so there is definitely nothing obvious. So, well, that means we need to measure if the capsule itself is okay, and if the connections are all given. So maybe this little switch, this switch is nothing else than a tone switch where you can vary your voice a little bit by putting a capacity into your signal path, which will change your voice a little bit. So maybe that there is something wrong with the switch, and yeah, that will be the next what we check, and yeah, see what we can find. Okay, so I've tried to put the meter in a way that you can read it and hear it a bit, because what I want to check first is if the connections are available, and therefore I want to check here from white should be the input, so that seems to be the mic, and brown is obviously the the ground, and the white one, when we follow the trace, don't know if you can really see it, it comes up here to this little switch, and like this, and now you see the connection via the switch is working, and when I put it in this way, we have the signal on one side, but it does not appear on the other side, and that is due to the fact that there is let us have a look. That is due to the fact that we have here the microphone, right? And the little switch is on one hand a bridge like this, and that is what we were able to measure. And when we switch it, we have the capacitor in between. So we do not have then a tone. So therefore, in any case, the trace right from the microphone itself over the switch, and now let's see if we have still continuity at the connector, and then we know that this trace is okay or not. The same we will do with our ground, with our mic ground. You see that is here the mic ground, and the next is let's check what is about our capsule itself. So maybe that the capsule is faulty, so that will be the next. Okay, so once again, from the white mic, let me call it plus, up to here it is okay, and now it doesn't work because now we have obviously the condenser in between. So let's switch it to the little bridge, and now you can see in here it is already there, and it is available at this connector solder point. So therefore I would say mic plus seems to be okay. So let's do the same with mic ground, and ground will be here and there, so that is okay. And now let's check the capsule itself, and yeah, I check at the input of the both wires, and I have switched on the beeper, and what you can read on the ohm meter is 670 ohm, which is not necessarily the capsule itself, because coming back to the schematic, you see that we have here a 680 ohm resistor, and the little switch is in a position where it is simply bridged, and we measure at both ends up at the capsule, and that means the 607 ohm we have measured could be the resistor, because you know the resistor is in parallel to the capsule, and I would expect that this capsule has as well something around I don't know, from 200 up to 600 ohm, or maybe a bit more. So it is suspect that we only measure 680. The value should be smaller, because in this condition two resistors are in parallel, and therefore the resistor should be smaller. But what we can do is we switch back to the capacity and measure again at this both points, and then this resistor is isolated, because you know the capacitor don't let DC voltage through, so therefore we should be able to measure directly the capsule. Okay, so that is still our yeah, let's go back to the beeper. So we have still come on, yeah, we have still the little bridge in place, and now we switch it, and you see now the capacitor is in between, so that's the reason why it doesn't beep. Now we switch back to normal resistor measurement, and let's do the same test. And yeah, what you see now, I'm directly at the capsule, and as this is a dynamic capsule, we should measure a resistor, but we don't. And now we are disconnected from this resistor in parallel, which we measure when we switch this switch, and then again we measure we measure this 680 ohm, which we have seen in the schematic. And yeah, I already said that this is a little bit suspect to me, because two resistors in parallel must give a lower resistance together. So therefore that is what I already thought. And now back the capacitor in between, you see now there is no resistor anymore, and therefore I would say this capsule is faulty. So that is obviously the reason for the problem. Yeah, and here once again I have disconnected the capsule from the PCB, and it is now directly connected to the ohm meter. And yeah, reflections again, very nice. And what you can see is what we have seen before. There is no resistor, and that is clear that our capsule itself is faulty. So we need to replace the capsule. So that is a problem. And to prove what I have said in the original dynamic microphone MH31 technical supplement issued by Yaesu, is telling us, I mean, it is already mentioned here, it is a dynamic microphone, and the microphone tube is dynamic, and that means on any dynamic microphones we should be able to read a resistance, and if not, it is definitely broken. Well, just to prove it, I have here a different dynamic capsule. This is the one out of our MH31, and this is another one. And have a look, it is hooked to the meter, and what we can see here is a resistor of approximately 450 ohm, and that is what I have already expected. And if I would now this capsule put in parallel to our 680 ohm resistor, we would nearly get the half complete resistor, both resistors in parallel. So therefore now it is clear we need a new capsule, or what we can do else is maybe put in electrode condenser capsule. Well, that have to be decided now. Yeah, what I have in stock is, as I already said, are some one second. So what I have in stock are electrode microphone capsule, which could be fit to this radio, to this microphone, but well, an electrode, so that's a kind of condenser microphone, works in a different way. This electrode microphone needs a supply voltage of about yeah, let me say 4 or 5 volt, and it needs a resistor to reduce the current, so we need to modify the board and the schematic if we decide to go for this capsule. But that might be the way to repair it, and maybe it is also a good idea, because in any case this you know, these dynamic capsules are not that good, so that is no high quality, so that is more cheap garbage. So it is really no, you do not lose anything if you know, this will not be replaced. So therefore it might be a better idea to take one of this electret microphones, and yeah, let's check if we gonna go for this solution. I have to check if we have plus here on the connector. So I guess we have, but I have to double check. On the schematic is nothing mentioned, but in any case connector point 6, you see there is something wired, but it is not used in the microphone itself. So I guess we have a supply voltage already available here at the microphone, and that would help to modify the board, that we are able to replace with this electret capsule. So therefore let's check if there is 5 volt or 10 volt or whatever somewhere. So I have already connect ground to ground, and yeah, the meter is hooked on, and on the board it must be a pin which does not go somewhere on the board, so it must be a connector without a trace, and as far as I can see it right here, there is only one, and that is this here. So that must be 6, which we already found here in the schematic, that it is wired, but there is no trace on the microphone PCB. So all the other points are connected somehow, but 6 is not connected. So, and we have here in reality only one point where we do not have a trace, and that is this one here. So let's check what we have here. Yeah, and have a look. There we have, as expected, our 5 volt, right? So that is our supply voltage for our electret capsule. So now it is much easier to replace the faulty dynamic by a nice electret capsule. And well, but there is another issue which we have to solve. So we need, as I said, to supply our electret capsule with a power supply, or with this 5 volt. But then we cannot leave this bridge here, because as I said, at this point we have to connect 5 volt from pin 6 over a resistor, but then we need a capacity right here as well, because we need a DC blocker. So we do not need the DC going this microphone wire down into the radio, and may destroy our microphone amplifier. So therefore this bridge can't be used anymore. So we need to put a second capacitor in here. But that is, by the way, a good idea as well, because this 0.33 microfarad can stay inside, and over the switch we put a smaller one. Let me say, I would go and try for 47 nanofarad, because then we have 2 different tone variation for the different bands. So the 0.33 microfarad would be then the switch position for FM, because with this bigger capacity you have more bases in your modulated signal. And for SSB transmission we should go for more highs in the transmission, and therefore we choose a smaller capacity. So we could use, or we should test how it works with the 47 nanofarad. So that is a value which I've already chosen in some other projects, and it worked. So yeah, so that is then the way to change between 2 different audio qualities. Let me call it qualities for the different modes for FM, which might be more for local talk purposes, and then for DXing on SSB you can then switch to the other solution. Yeah, and therefore I have already modified the schematic. You can see that now the 5 volt which come here into pin 6 will be going now over 8.2 kilo resistor directly to the mic, to supply the mic with 5 volt, and the resistor is just to reduce the current. Then we put here a little one, a picofarad capacity to suppress distortions. And then we have to modify the switch. So you can see we have 1, 2, 3 connectors, and that means we can switch 2 different yeah, we can switch in two different ways, and therefore, as I said before, we can't use this bridge anymore. So therefore, we will switch it this way with two capacitors, and yeah, modifying the switch and use this connector as well, we can then switch between two capacitors, and that means yeah, we have different audio for the different modes. And yeah, therefore I have already taken out the capacitor which was inside, and as you can see, we have three pins here, and now the switch is on one side, so there is the connection, and on this side is nothing. And when I now switch it over, now it is flipped over, now we have here, you see, the connection, and this one is disconnected. And that is the way where how we can now fit in this solution, so that we are able to switch between this both conditions, and that is what we are going for. So yeah, we put this inside together with the 47 nanofarad, and then we have to add our resistor to get the 5 volt to the capsule. Yeah, and then we will see whether it works or not. Okay, the modifications for this both capacitors are done, so we can now switch between these two capacities, which results in a bit different modulation. So for single sideband we have now with this little capacitor more highs, and on FM for instance we have a bit more basses with this capacity. And yeah, I have hooked on my capacitor meter, which is here, and it is connected to the mic wire, and on the other hand there is our connector which goes into the radio, and on this position we have our 46 nanofarad, so that is the one which we put here, so that is now on this position. And when we flip it over, I have to change the meter, and now you can see that we have our 0.3 microfarad, which is this here. So two positions, first position 0.3 micro, and flipping over to this position, and we have our 46 nanofarad. So that is the first modification. So yeah, this is, as I already said before, good for speaking on different modes, but as well it is essential that these capacitors in either way will block the DC, which we need to supply to this point here, because as I already said, our electrode capsules need 5 volt or whatever. Maximum, I guess it is specified maximum 10 volt, but 5 volt or a bit less is always a very good idea. So yeah, we need to supply our 5 volt right from this solder point here down below, and yeah, that will be our next step. Yeah, our 5 volt supply is now connected. So from the 5 volt point which we found before, and what you can see here, this is now our resistor for controlling the current, and yeah, to this point we have to connect our electrode capsule, and then we can go for a first test. Okay. Yeah, only for testing the circuit I have now hooked on the new microphone. The radio is set up to 14200, and what we want to check is if it works with this new modification in this new circuitry. And well, the lab monitor is hooked on as well, but what we want to see is if we see audio when we talk to it. So I want to take it and press, and yeah, you see nothing, but when I'm going to the microphone, 1 2 1 2 1 2 1 2, so, and here is our feedback. 1 2 3 audio, 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 1 2 3 4. So that means our circuit is up and running, so that is good. And now yeah, we need to fit in this microphone here to this microphone housing, and then we can finally mount it back together, and yeah, then work will be done. So that will be now next step. Yeah, the new capsule is in, so it is glued with hot glue, and I have already put some foam around it, so that is essential that the capsule will have a good sound. And now I will cover it with some additional foam, that it is closed all around, and then we hope that at least we will have a nice and clear modulation. Yeah, you can see a lot of foam is now inside to cover the distance and give the capsule a bit pressure from behind. And yeah, now we have to connect it as already shown, and then we are very close to finish this job. Okay, have a look. So it is all connected. It is up and running. Let's check it. 1, 2, 1, 2, 3. Yeah, you can hear it over the SSB lab monitor. Audio, audio, 1, 2, 3, 1, 2, 3. 1, 2, 3, test, test, audio. Yeah, therefore, I can say repair is done, and yeah, I will put the housing back together, but anyway, everything is fine, it works. Unfortunately, you cannot really hear the sound over the lab monitor speaker. Therefore, we have really to connect some headphones to really judge what the sound is. So sorry, I can't really demonstrate it here on the internal speaker, but believe me, sound is good on the two different positions for FM and single side band. So that's it. Repair is done, and I hope you enjoyed it a little bit. And yeah, if you think it was good, please thumbs up. Thank you, and catch you next time. Bye.